Hello, my name is Ben Zimmer, and I'd like to welcome you to the second installment of the LabVIEW Mastery Tip Jar. In this video blog, I present hints and tips that will be useful to LabVIEW users of all levels. So I'm kind of continuing the theme from last week, where I talked about the example finder, although this week I'm talking about the OpenG Library. OpenG is the name of the LabVIEW open source community. What I think is so great about the OpenG library of VIs is that it contains so many VIs that we use over and over and over again. I think the best and perhaps most simple example is just array empty. Normally when we check whether an array is empty, it takes at least two steps. We have to calculate the array size and then check whether that size is equal to 0. Now if you're like me, you've probably written a SubVI to do that and used it many times and then lost it and then recreated it. And if you calculate over the years how much time you spend checking whether an array is empty, in particular if it's a multidimensional array, you realize that, although it's not a lot of time, it's certainly non-trivial and it does interrupt your workflow. So that's just one example of the kind of function that's inside the OpenG library. We're going to talk about a few more really interesting examples. First, we're going to go through the install process. So we start off going to the openg.org website. If we were to key in openg.org to our web browser, it would bring us to the home wiki page of the OpenG community. And we see right near the top here, looking for OpenG VIs, read this document on how to install it. Before we go through the installation of the OpenG libraries, I just want to briefly mention that not so long ago, the installation of the OpenG libraries was really simplified. Jim Kring and his team at JKI Soft have created the VI Package Manager. And this tool is what we use to install OpenG libraries into LabVIEW. What's really nice about the VI Package Manager is it allows you to install different versions of each of the toolkits into your different instances of LabVIEW. If you're like me and you have 4 or maybe 5 versions of LabVIEW sitting on your development machine, that's a really helpful tool, particularly because some versions of the OpenG libraries are not compatible with some versions of LabVIEW. So we click here, and the link is provided at the bottom of the video blog entry if you want to just follow it directly. And we're brought to a discussion forum here which tells us exactly how to install. The first thing we want to do is download and install the VI Package Manager. We're going to choose the Community Edition, which is free. It allows us to install and download the OpenG libraries. Through the magic of streaming Flash video, the download and installation process is now complete, and now we've got our VI Package Manager open. First thing we're going to do is add a version of LabVIEW. We click to register our version of LabVIEW. We navigate to the Program Files directory, National Instruments. We choose the version of LabVIEW we want to use. This time I'll register my LabVIEW 8.5 version, and we choose the LabVIEW EXE version. Next, it asks us to configure the LabVIEW port and just make sure that the VI Package Manager can communicate with LabVIEW. We click Test. It actually tries to open LabVIEW, and then it reports that it successfully is connected. So now that we've registered our version of LabVIEW, what we need to do now is check the network for all packages. What this does is it goes to the network and queries for the latest versions of all the different OpenG toolkits. So it tells us here we have a list of all the different packages that have been found that are compatible, and we can choose to selectively turn them on or off. For now, I'll just let everything install. So after a few minutes, the download and the installation process will be complete. You may be prompted to accept some license agreements. You may be prompted with some other messages depending on the version of LabVIEW and the version of the OS you're using. But at the end of this, the selected OpenG library packages will have been installed into your version of LabVIEW. So we go into LabVIEW now on our block diagram, and we right-click to bring up the functions palette. We see that we have a new subcategory here called OpenG. Just pin this guy down. I highly recommend spending a couple hours playing with and going through all of these individual functions. You're going to find things that you use all the time, and you're going to find things that you say, geez, I really wish that I had thought to make that a SubVI and put it away in a library so that I can use it over and over and over again. The benefit of using these OpenG functions is that it's really easy to make sure that all of your development computers have the OpenG toolkit. You take advantage of the VI Package Manager. You can go ahead and use these functions in code that you distribute as well as code that you build executables for. You just have to be very careful to pay attention to the OpenG licensing. I've put a link at the bottom of the video blog page as well so that you can take a look at the licensing parameters. I'm not going to take the time to give a complete tour of all of the OpenG toolkits. What I am going to do is just give a very brief summary of the palette organization here. What we see in this palette is a structure very similar to the standard functions palette. We see that there's a series of array tools, some Boolean tools, some comparison tools, error handling, among others. It's very easy to navigate this palette, and the structure should be very familiar. Let's start with the example I mentioned before, which is the empty array. We can find this in the OpenG Array Tools subpalette over here called empty array. If we take a look at its block diagram, it takes the array, checks the array size, does an array compare to see if it's 0, and ORs all the array elements. We can also observe, if we take a look at the front panel, that a copy of the licensing information is here. So again, I invite you in particular to take a look in great detail at the Array Tools subpalette. There's an awful lot of very useful stuff here. The next function I want to briefly talk about is in the OpenG Picture Tools. It's this one here called Draw Image from File. What this one does, and we can see if we activate the context help, is it opens up a bitmap, a JPEG, or a PNG file and draws it into a picture control. This is a really helpful and useful functionality that we often don't have access to unless we're using the NI Vision toolkit. So all we need to do is on our front panel create a picture indicator. Put it here. I'll just right click to enable the scroll bars. I'll also create a path control so that we can specify which file we want to load. And I'll just go ahead and select this photo. Now when we connect everything up, and we run the VI, we see that we're indeed able to load a photo into our picture control. In this case it's a JPEG, but it works just as well with a bitmap and a PNG. The next function that I want to talk about is write INI cluster. Let's just open a new VI. This function is available here under the OpenG variant config file VIs. It's called write INI cluster. We're going to take that, and also the OpenG toolkit has conveniently included two other functions that we need, which is the open config VI and close config VI. What we're going to do with this function is take any data structure contained within a cluster and write it in an almost completely human readable form into an INI file. Quite often when you're working on code and you have the requirement of dumping the information about a particular data structure or a particular configuration into an audit file or some other similar type of file, this function performs the task absolutely easily. So let's start on our front panel. We're again going to create a path control. INI path. We're going to create a cluster. Inside this cluster we'll put some information. We'll put in, say, an array of numerics. We'll call it data. Put some values inside. We'll also put some other information, maybe a Boolean whose value is set to true, a string, and what this function is going to do is it's going to take this cluster and write it into an INI file. So let's also specify our path. Before we do so, let's change the browse options here to allow us to specify either a new or existing file. Now let's go ahead and enter a path. We'll call it INI file test at INI. Make that a little bigger so we can check it. And now just connect everything up. So we're going to specify our path into this function, which is the open config data file, which is then going to create the config data file. Next, we connect it up to our write INI cluster. And we put our cluster into the data input. Notice that this is a variant input, so it took any data type and it performed the coercion appropriately. And then we'll close the file at the end. So now when we write this, everything behaves. If we go navigate to that file and we open it up, we see that it's a text file, which is INI formatted, meaning each data structure we put into it takes its name as the structure header, and all the data is inside there. So we have our data, size 3, and then the entries. We have Boolean equals true and info equals test ran successfully. This function works for incredibly complicated data structures or very simple ones like this. And you'll see that it's a very useful way to take a copy of information from your VI into a nearly human readable format. So there's a very quick summary of 3 of the OpenG functions that I find I use an awful lot. As mentioned, there's a whole bunch more other ones, and I think it's really a valuable use of time to spend a couple hours poking through them and seeing what you can use in your daily activities. Thank you very much for watching this installment of the video blog. As always, please feel free to post any comments you have, in particular, any other OpenG functions that you find you use an awful lot. Bye for now.